Alright, here we go again. Today we're solving equations with absolute values in the equation. So let's start off with a little definition of what we mean when we say absolute value. For us, the absolute value thing will be something that we attach to real numbers. In other words, we will take absolute values of real numbers and we will define them as follows. The absolute value of x is equal to either the x itself. If x is already positive, there's nothing to do. The absolute value of x is already x. That's the case when x is positive or 0. However, if x is less than 0, if x is negative, that is, then the absolute value of x will be defined as negative x. What this does is it flips the sign. If x was negative to begin with already, attaching another negative will make it negative negative, which would turn it into a positive. So roughly speaking, what this says is, it says the following: the absolute value of x, well, if it's the same thing as x if it's already positive, or just change the sign if it's negative. That's a good way to, or one good way to read that definition. Let's do some examples here. So the absolute value of x, the absolute value of 3, that would be equal to 3 since 3 is already positive. That's just by definition of absolute value. The absolute value of negative 5, that would be negative 5. That's by definition of absolute value. Since it was negative, I gotta add on this other negative, which of course would make it 5 by inspection. And so that's how this definition works. It says if the number is positive already, leave it alone. If it's negative, change the sign by adding another negative. So this would look like negative 20, which of course is equal to 20. These are all examples of the definition of absolute value being defined. You should be cautious here. When somebody gives the absolute value of w, you don't know if it's just w or not. That's up to debate here, because for us in our class, these variables, these letters usually represent real numbers. Trouble is, we don't always know which real number it represents. So if it happened to represent a positive number, then that would be correct, would be done. There's nothing to do. But if it happened to represent a negative number, then this would be very bad. So while these ones are easy because we already know what the number is, in this case the number is negative, so we just add another negative. That's fine. If it's positive, you leave it alone. When you have a variable, it's not so clear, so we just leave it like that until we know something else. And that something else is coming up in about 3, 2, 1 seconds right here. The absolute value theorem. This one will help us say something about the case when we have just variables involved in there. It says, well, we already know that the absolute value is either positive or negative of the original thing inside the absolute value. So if it happened to be that the absolute value of some variable is equal to a, then we know for sure it's either equal to a if x was already positive, or negative a if x was negative. That's going to help us get rid of these absolute values and solve equations that have absolute values in them. For example, take this equation. So this is, you can think about it as a riddle. I've got a number x here. The absolute value of a number is equal to 2. That's the given. What can you say about the number? Well, I can say that either x is equal to 2, or I can say that x was equal to negative 2. That's the absolute value theorem. It's the perfect tool to get rid of these absolute values. If you have absolute values on the left hand side, just get rid of them. It's equal to the right side, or it's equal to the negative of the right hand side, and you're done. Okay, and by the way, these are the only two real numbers where you take the absolute value and you get 2, either 2 or negative 2. Let's do that again. If somebody gives you this equation, the absolute value of x equals 7, you can proceed by saying that, well, either x is equal to 7 or x is equal to negative 7, and you can quote the absolute value theorem for that. Nice little fact. A way of getting the rid of the absolute values is make it equal to 7 or negative 7. Okay. By the way, this is another way to think about this is you exchange the absolute value equation, you exchange it for two little baby equations that have no absolute values. So in some sense these are easier. You exchange a hard one for a couple easy ones. Of course this is super easy, but they get a little bit more interesting. Take this one for example. Still you have the absolute value of blah equals 3, so I can say, well, either blah is equal to 3 or blah is equal to negative 3 by the absolute value theorem. What I've done is I've exchanged my absolute value equation for two little baby equations that have no absolute values, and so they're easier. This one I would add 4 to both sides, and I would get that x is equal to 7 by cancellation law of addition. and some other easy axioms. Here I would add a positive 4 to both sides, and that would give me 1, again by cancellation law of addition, and some easy axioms. And so I've got my solution. My solution is two possible numbers, 7 or 1. You should always check these to make sure they work. If I plug in 7 here, of course I get 7 minus 4, which is 3. The absolute value of 3 is 3. If I plug in 1, I get absolute value of negative 3. The absolute value of negative 3 is 3. Good. Okay, you could check these. They get a little bit more interesting here. The absolute value of 2x minus 4 is equal to 1. We're going to use the same technique. We will get rid of the absolute values. There we go. Me getting rid of the absolute values. Set it equal to 1, or 2x minus 4 is equal to negative 1. Big or here in the middle. You've exchanged your absolute value equation here for a couple easy equations that have no absolute values. Here I would add 4 to both sides. I would kill the coefficient. Cancellation law of addition and other easy axioms. Kill the coefficient. That's one possibility. 2x is equal to, let's see, I'm adding 4 to both sides, so that would make it a positive 3. X is equal to 3 halves. Cancellation law of addition. Some easy axioms. Kill the coefficient. The thing that made it all happen was the absolute value theorem right here. That's how you get rid of absolute values. Okay, pretty easy, right? Sometimes it may even be more interesting where they have a 3 here. The absolute value theorem doesn't apply when you have a 3 here. So it might be a good idea to get rid of the 3 here. I could do that by slapping both sides by a 1/3 and a 1/3. I could reassociate these. These absolute values act like parentheses, so I can reassociate it with a 1/3 and a 3, and that's gone, giving me that 2x minus 4 is equal to, 2x minus 4 absolute value is equal to 5/3 x minus 5/3. I did distributive law and some other easy axioms. And now I've got that the absolute value of something is equal to something else. Now I do my absolute value theorem. So that would give me 2x minus 4 is equal to 5 over 3 x minus 5 over 3. Or 2x minus 4 is equal to 5 over 3 x minus 5 over 3 with a negative. Okay, it's either equal to that with a positive version of it or the negative version of it. So I did that positive version of it or that negative version of it. This will give me that 2x minus 5/3 x is equal to 4 minus 5 over 3. That's me bringing all the x's to one side and no x's on the other side. And then I factor out the x's, so that would give me x 2 minus 5 over 3 is equal to 4 minus 5 over 3. And of course last I just have to kill a coefficient and divide all that. And simplify if you like. I'll do it right here because I can see that the screen doesn't fit this awesome ideas anymore. So I'll have x is equal to 4 minus 5 over 3 all over 2 minus 5 over 3. The key step here was the absolute value theorem. All the rest of it is by inspections, things we've done over and over again. Alright, that's one of the solutions. However, we have another possibility, this possibility, that it was equal to the negative. Every time you break this up, the absolute value theorem, you get two possibilities. So it's like having two separate equations that you've got to solve. So 2x minus 4 would be equal to negative 5 over 3x plus 5 over 3. That's just distributive law. And I continue the same way, move all the x's to one side. So that would give us 5/3 x is equal to 4 plus 5 over 3. Cancellation law of addition and minor things. I gather all the x's. These are linear, so I'm following the linear strategy here. Free the x's, move them all to one side, collect the x's, and kill the coefficients. So I have 2 plus 5 over 3 times x, and that's equal to 4 plus 5 over 3, and that's distributive law. And finally, all I gotta do here is kill the coefficient. So I'll continue up here, and that would give me that x is equal to 4 plus 5 over 3 all over 2 plus 5 over 3. And again, you can simplify if you like. And also, once you simplify, you can check it in here to make sure it works. If you want to really know if you did it right, if you want to double check, it's always good to check your answers back on the original problem to see that you did it right. Okay, here's a really good example of why you should check your answers. Let's take this one and say, okay, this is 3x plus 1 is equal to negative 3, or 3x plus 1 is equal to negative 3. That's the absolute value theorem that says if this, then that. If this is true, then that is true. And then here we get that 3x is equal to negative 4. So x is equal to negative 4 over 3. Or 3x is equal to, this would be positive 3, but I subtract 1, that will give me 2. So x will be equal to 2/3 by killing the coefficient. So I've got my two answers, but if I check these, try to check one of them, for example, check this one. 3 times 2/3 plus 1, absolute value. What is that equal to? Well, the 3's would cancel here, and that would just give you 2. 2 plus 1 is 3. That would give you 3. Absolute value of 3, which is equal to 3. And it's not equal to negative 3, so this doesn't work. In fact, what happened here? This one also doesn't work if you check it. The thing that happens here is that there's a big old if here. If this is true, if this is true, then that is true. It doesn't say this always true. This is a big old if here. And the trouble here that this was never had a chance to be true in the first place, because the absolute value of any number wouldn't be a negative number. So it was failing from the get-go. And so you should be careful with these. This is a big old if, so when you get done with it, you should go back and check your answers, because if you don't, you could get into some trouble here. Okay? Just a little warning. Check your answers at the end. Or if you're very sharp at this, you would have perceived at it from the beginning. The absolute value of a number won't be negative 3. It'll always be a positive 3 maybe, or a positive something. Alright. You can also do this with multiple absolute values. So here, take this example. This would be 3x plus 1 is equal to absolute value of x plus 2, or 3x plus 1 is equal to negative absolute value of x plus 2. The positive or the negative, that's AVT. Now here this is interesting, because now you have absolute value here and you have a 2 here. What you could do is subtract a 2 from both sides, and you have 3x minus 1 is equal to absolute value of x. Cancellation law of addition. And here you could use the AVT again to get rid of that absolute value. So this would split up into two pieces. X equals 3x minus 1, or x equals negative 3x minus 1. Again, the AVT. And so this one would also do the same. It would break up into two pieces. Because you have two absolute values, this will break up into 4 pieces, and you'll have 4 possible choices. Let me elaborate on that. This gives you 3x plus 1 is equal to negative absolute value of x minus 2. This is just by distributive law. I'll move the x over here and this over here, so I get the absolute value of x is, this piece got moved to the left side, everything else gets moved to the right hand side. So I have negative 3x, this is minus 1, and minus 2 would give you minus 3. I'll just BI this piece, and now I've got the absolute value of x is equal to blah. I can use my ABT here, and so I get that x is equal to negative 3x minus 3, or x is equal to negative 3x minus 3 by ABT. And so now look at them. I've got 1, 2, 3, 4 possible equations. So I took my crazy problem here with 2 absolute values, and I broke it up into 4 easy problems that have no absolute values. These should be very doable. I'll let you finish these, but this might be one way to handle occasions when you have more than one absolute value. Alright, I think we should take a little break here. We'll see you guys here next time with some more solving of equations. Alright, bye.